Okay, so now most of this chapter is about reflection and refraction, and we'll move into reflection soon. But first, before we do this, as we're discussing these wave phenomena, it's helpful to think of light as a traveling wave front. I'll show you what I mean here. But as light rays travel through space in a straight line, as they travel through space in a straight line, the wavefront is a point at the head of these waves. Or as a surface, rather, at the head of these waves. So if I have these light rays, I would draw these just as like a single line. Let me change my color here. I would draw these as a single line. This would be a light ray. I imagine wave fronts all along this that is actually made up of a collection of rays. Right? And so this will be useful, for example, when we get into refraction. I'll talk about light rays as they move here. And we'll imagine that we'll have a series of wave fronts that is impinging upon this medium. And then we'll find that these wave fronts, that they'll bend from one direction to the other. Right, so it is useful to think of these in terms of wave fronts as just a collection of waves or a collection of straight rays as they move along. Now first, let's look at the law of reflection. The law of reflection is very simple. I've already said it basically before when we were talking about this. Remember, this was the idea that Newton believed to demonstrate the particle nature of light, and it does in fact demonstrate the particle nature of light. And it just says that the angle of incidence is equal to the angle of reflection. Or I could just say theta I, which is the incident angle, equals theta R. You can do this with a tennis ball. Go home, take a tennis ball, you bounce it off of the ground. So you throw it at a certain angle on the ground, and then it's going to bounce up at a certain angle. All right, so you can try this if you like. Then you bounce the object. This would be our theta I, and this angle is our theta R. And our incident angle is always equal to our reflected angle. The incident angle is always equal to the reflected angle. Here's a quick question here. This is a test for your geometry. Now, this says that theta I is equal to 30 degrees. As it's drawn here, theta I looks like it's 45, theta 1 rather, looks like it's 45 degrees, but it's not. So you want to step through here and ask yourself, well, if this is 30 degrees, I know that this is 30 degrees. So what does that say about this angle? What does that say about this angle? And what does it say about this angle? And then you can find out what is theta 2. So I'll leave you to try that on your own, and next we'll go to law of refraction.